Welcome, Algebra 2, to Words to Review for Chapter 4. We've got a lot of them to do today, so I'll try to keep them quick. Quadratic function is a quadratic function has highest power is a squared. Y equals x squared is a quadratic function. A parabola is what is called the graph of a quadratic function. Okay, the graph of a quadratic function. The vertex is just like the vertex for a absolute value. It's that lowest point or it's that highest point. So it's the lowest or the highest point on a parabola. The axis of symmetry is an imaginary line that cuts the parabola in two equal pieces. All right, so here is a parabola. Let me put this in here. It's U-shaped. And just like the absolute values symbols, there's an axis of symmetry going through the vertex. All right, minimum value. That is the vertex of a y equals x squared. A maximum value is the vertex of a y equals negative x squared. Vertex form. Let me see. I don't think there was a standard. I don't see a standard form. Let me add in here. Let me add to one of your words here. Standard form for a quad is y equals ax squared plus bx plus c. This is standard form for a quadratic. Vertex form, y equals x minus h squared plus k. That should look very familiar, and I think I forgot to put an a in front of that. That's vertex form. It's very, very similar to vertex form for an absolute value equation. Intercept form, y equals a x minus p x minus q. We'll talk about what each of these things mean. Monomial is an equation or an expression of one term. Binomial would be an expression of two terms. And for both of these, you should add when it's in simplest form. A trinomial is an expression with three terms. I know, it's amazing. A quadratic equation is basically exactly what we've seen before. I'll write standard form here, y equals ax squared plus bx plus c. The root of an equation, we're going to say is just a solution. A zero of a function could also be considered a solution. Square root is this. Hold on. I'm going to write what you usually see as this. That's a square root. And we assume something here. You assume that there's a 2 here. Because this actual bar thing that looks like long division, this is a radical. And you can have a lot of different types of radicals. You could have a square root, or a cube root, or a fourth root, or a fifth root. But the radical is right there. The radicand is the number inside of it. So the radical, or the square root of 16. The 16 is the radicand. Rationalizing the denominator. That means you can have no rads down low. So you cannot have 3 over the square root of 3. That's not proper etiquette. Conjugates. For lack of a better term, I'm going to say conjugates cancel things out. Conjugates usually come in pairs. And we'll talk about conjugates a little more later. Imaginary unit I, I'm going to say I equals the square root of -1. Now, for a lot of these things here, the imaginary stuff, we're going to use your calculator. So you're going to want to be bringing those to class all the time. A complex number is a number with a real term and an imaginary term. Imaginary numbers have I in it. Complex conjugates. Again, they cancel things out. An example of a complex conjugates would be 2 plus 3i and 2 minus 3i. Something here, when you add these together, something cancels out. When you multiply, something cancels out. Absolute value of a complex number. Let me add over here on a complex number. Let me add that it's usually a plus bi. So an absolute value, the absolute value of a plus bi is equal to the square root of a squared minus b squared. So you need to make this a squared plus b squared. Completing the square is a cool method to solve. Complex quadratic formula is another method to solve. The discriminant tells the number of solutions. And the kind of solutions. A complex plane. The complex plane is basically your normal ordered pair or coordinate plane, except now instead of x, we have real numbers here and imaginary numbers in the vertical plane. So basically, if you had the number 2 minus 3i, that would be a 2 real and a minus 3 imaginary. This one would be 2 on the real scale and then 3i on the imaginary. So that's how that works out. All right, quadratic inequality in two variables. It's just an equation. It's a quad with an inequality. In one variable, it's a quad with an inequality. And the best fitting quadratic model is an equation that fits some data. Okay, there's an equation that fits some data, and you go from there. All right, and that's pretty much it. All right, good luck.